Alright, let's look at this problem. So we want to simplify some of these radicals. So A, we have square root of 500. Now this is a bigger number, but again, if you can recognize that, oh, this is square root of 100 times square root of 5. 100 is a perfect square. This is 10 times 10. So you can say this is 10 square root of 5, and you're done. Okay, so this is sort of the quick and easy way. All right, but if you can't recognize that, then you're going to have 500, and let's say, oh, I can divide this by 2 and 250. This is prime, so I'm going to circle it. This is 2 and 125. This is 5 times 25. And this is 5 times 5. Right, so every time you kind of divide by a prime number, you circle it. Okay? So now I'm going to rewrite it. I'm going to say 500 is 2 squared. And then there's like 3 5s. All right, but we're going to, because we want to be able to divide by 2, I'm going to pair things up. I'm going to take this like 5 to the 2. I'm going to take these together, and I'm going to leave this by itself. Okay? So the goal is to be able to divide the exponents by this index. So if you have things that are kind of left over, then you write them separately. Okay? Alright, so now we have square root of 2 squared, and square root of 5 squared, and square root of 5. Okay, so these come out of the radical because you can divide. So we have 2 to the 1 times 5 to the 1, and then square root of 5. And these multiply, and we get 10 square root of 5. Alright? Okay, let's look at part B. See if I can put this down here and look at part B. Alright, so cube root of 16. Okay? The quick way, I know that 8 is a perfect cube, so I can write this as cube root of 8 times cube root of 2. Cube root of 8 is 2, and then this 2 stays inside of the cube root. Okay? If you get comfortable with this, then it's nice. It makes it a lot quicker. Alright, the other way is that I'm going to break this up. This is 2 times 8. This is 2 times 4. This is 2 times 2. Let's circle our primes. Alright? So now we want to write this. You want to make groups of 3. So this index of 3 tells you that we need exponents that are divisible by 3. Okay, so this is going to be cube root of 2 to the 3. Basically, we're taking these. But then we have this left over by itself. Okay? So we have cube root of 2 to the 3 times cube root of 2. This ones we can divide the exponents, and we get 2 to the 1. But this one will not simplify anymore. So this is our final answer. Okay, so again, this is, you should get the same answer. This is sort of a quicker way. This is a more extensive way, but really useful if you can't see right away how your number breaks up into like that perfect cube times something else. Alright, let's look at C. So I'm going to move this down. Alright, C, 4th root of 243. Alright, now this is, I kind of know how to break it up because I've sort of looked at numbers forever, but this is a little bit hard for me to see too, especially kind of with the higher index roots. It's kind of hard to kind of recognize, oh, this is a perfect 4th root. Like I can remember perfect squares and perfect cubes quite well, but perfect 4th roots, those are a little bit harder to remember. So I'm going to do the factor tree on this straight away. So it doesn't divide by 2. I think it divides by 3. So it's 3 times 81. Oops. What just happened there? Right. And this 81 is 9 times 9. Alright, neither of these are prime, so we can break them up more. 3 times 3. And this is 3 times 3. Alright, let's see. So fourth, we have an index of 4 here. We want to collect groups of 4. So here's a group of 4 that we're going to put together. So we have 4th root of 3 to the 4. But then we have this one left over times 3. Okay? So 4th root of 3 to the 4 times 4th root of 3. These divide and I get 3 to the 1. That doesn't have a radical anymore. And then a 4th root of 3. That doesn't simplify anymore. Alright, that's it for this example.